Hello, good morning, friends. Today's topic is a scalar product of two vectors. So, this scalar product is also called as dot products. Okay. So, let us discuss in details what is scalar product and dot products and explain about its characteristics. So, now see here for that purpose, here we are considering two vectors. So, that vectors are like this. So, suppose two vectors are here like this. So this vector is vector A, second one is vector B, and whatever may be the angle inclination between these two vectors, that angle inclination is supposed to be theta. So theta is the angle between vector A and vector B. Now how we can here consider the dot product, or we can say scalar product of these given two vectors. So for that purpose, so you should remember the concept, or we can the definition of this scalar product. That definition is the scalar product of two vectors is the product of magnitudes of products of magnitudes of given vectors and cosine angle between them is called scalar product, or we can say dot product. So this is the concept for dot product or scalar product. So scalar product means what? Scalar products means the product of magnitudes. The product of magnitudes is, it means what? The product of magnitudes of given vectors and cosine angle between them. Between them means between two vectors. Now see what is the dot product of these two given vectors. So here we have to write vector A and vector B. So therefore we can write here vector A dot vector B. So this dot represents it is a dot product, or we can say scalar product. See this dot product is also called as scalar product. So this dot represents definitely a scalar product is there. Okay, so how we can read it? Vector A dot vector B. Now if vector A dot vector B is there, so what is the scalar product? So the product of magnitude. So just we are taking here product of magnitudes of given vectors. So what is the magnitude of vector A and vector B? Now see how we can represent the magnitudes. So to represent the magnitude, we must know, that is, if vector A is there, then if we want to write this vector A in the mod, so if we write vector A in the mod of vector A, so this mod of vector A is called as magnitude, and this one is vector. So this is vector and this is magnitude. So this magnitude can be written as mod of A mod of vector A, or we can write simply A. So do not put here a bar, or we can say arrow on the head of this capital letter A. Just you have to write simply A. Okay. So this vector A can be represented mod of vector A or simply A. So mod of vector A or simply A, these are the representation of the magnitude. means we can represent any vector in magnitude. Suppose if we consider here vector b, then how we can write its magnitude? Either you can write mod of vector b, or you can write simply b. So mod of vector b or simply b, so these are the magnitudes of vector b. So similarly here we can write that is vector a. So the magnitude of vector a, the magnitude of vector a is a, and the magnitude of vector b is b. So this AB represents the magnitude of vector a and b. Okay, so this is the product of magnitude of given vectors. Okay, so whatever may be the vectors which are given to us, so just we are taking their production of magnitudes of vector given vector, that is vector a and vector b. So the vector a and vector b, this is the magnitude of vectors, given vectors. Now which theta we can apply here? Cosine theta, that is cos theta. So in this way the dot product or cross product, the dot product or scalar product of these given two vectors is AB cos theta. Similarly, if we can consider that is vector P and vector Q, dot vector Q, two vectors are there. Vector P and vector Q, two vectors are there. What is the dot product of these two vectors? Just you have to write magnitude of vector P, that is P, then magnitude of vector Q, that is Q, and cosine angle between them, that is cos theta. So PQ cos theta is the dot product, or we can say scalar product of these given two vectors. Okay. So you have to remember the definition about the scalar product, means how we can consider the dot product or scalar product of any two given vectors. So let us discuss about some properties, or we can say characteristics of this scalar product or dot product. So first characteristics is characteristics. Now which characteristics are there of dot products? So first characteristics is like that scalar product of two vectors is a scalar quantity. Scalar product of two vectors scalar product of two vectors is a scalar quantity. So this is the first characteristics of dot product, means whatever may be the dot product of these two given vectors, so that dot product is definitely which quantity? Scalar quantity. We have seen already scalar quantity means what and vector quantity means what. So scalar quantity means what? Just it has only magnitude. Okay, it does not require at any cost directions. What about vector quantity? Vector quantity means what? Which require both magnitude as well as directions. So see here, direction is not necessary in this case, therefore this one is the first characteristics. What about the second characteristics of this dot product? Scalar product of two vectors has no direction. Similarly, scalar product of two vectors, scalar product of two vectors has no direction. Definitely they do not have any direction. Why? Because whatever may be the dot product of given vectors, so that dot product must be scalar quantity. It means they do not require any type of direction. So this is the meaning of this second characteristics and first characteristics. Now third characteristics is it obeys the commutative law of multiplication. Third characteristics, that is it obeys commutative law. It obeys commutative law of multiplication. Now what is the meaning of this third characteristics? Commutative law means what? So suppose we are taking here two vectors, that is vector A and vector B, and the dot product of these two vectors, that is vector A and vector B, is AB cos theta. Okay, so if we consider vector A and vector B, two vectors are there. So vector A dot vector B is equal to the dot product of these two vectors is AB cos theta, or we can say vector B dot vector A is equal to BA cos theta. So this is the dot product of these two given vectors. If so therefore we can write what? Vector A dot vector B is exactly equal to vector B dot vector A. So this is nothing but it is a commutative law of multiplication. It means that if you write vector A dot vector B, so vector A dot vector B can be written as vector B dot vector A. So this is the commutative law of multiplication. So this dot product, or we can say scalar product, obeys this commutative law of multiplication. If vector A dot vector B is there, so we can write vector B dot vector A also. So this is nothing but it is a commutative law. So remaining characteristics we will discuss tomorrow. So till then, thanks.